Continuing our comparison of additive versus traditional manufacturing, the next point to consider is the complexity of the part. The figures are demonstrating where it becomes more expensive and difficult for traditional manufacturing to create the parts. For example, undercuts, although doable, significantly increase the part time and cost. The simpler the shape, the easier it is for traditional manufacturing methods. The more complex the shape, the greater the cost. However, this is not true for 3D printing. Fine details and undercuts similar to these are easy and do not add significantly to the cost. Support structures and scaffolding can be used. Sometimes they may interfere with the fine details, but are typically easily removed. Again, in CNC machining, we can make very complex shapes as we can with additive manufacturing, but the removal process is very time consuming, and creating the part program also adds a significant cost. If we look at the example timeline here to compare the traditional machining of a complex part to that of a printed shape, we can clearly see that 3D printing can save significant time as long as it meets the material properties required. Here we see a comparison of typical workflow from the design stage to the finished product with the timeline in days. This comparison is comparing the exact same part created in titanium, a very difficult to machine material. Next, we're going to look at several case stories where additive manufacturing has seen a significant cost savings for parts that were traditionally manufactured. The part shown here was used in the packaging line and would break regularly. Lead time to have a new part machined was quite extensive, and it was becoming harder and harder for the company to find a machine shop capable of making it at a reasonable cost. The arms, which typically broke at least once a week, would cause a downtime period, costing roughly £5,000 a day. By switching to a 3D printed part, it was easier to maintain stock and create the part out of a tough nylon with reinforced carbon fiber, Kevlar or fiberglass. Such parts, when properly printed, can be stronger than 6061 aluminum. Another example of where 3D printing can significantly decrease part cost is in this assembly. Rather than traditionally assembling 3 or more components to make the ductwork, a more complex and efficient ductwork shape could be 3D printed. It was easier to design, there was less supply chain, there's no tooling, there's less labor, no assembly error or cost, less certification. It was a lighter part and a stronger and better part. As shown here, it's not uncommon for 3D printed parts to replace several components that need assembly, which is significantly cheaper than machining and assembling the components. Here we see an assembly of 5 different parts and 24 fasteners versus one 3D printed part. Similar over here, we have 6 parts requiring assembly, or we could 3D print one part at a cost of $19.58 a part compared to $29.79 a part, reducing the cost by 34.3%. 3D printing of complex shapes for investment casting can also be a huge time saver.